In this video we're going to review graphing quadratic functions. The quadratic functions we're going to review are the ones in standard form. Standard form, remember, is ax squared plus bx plus c. So the a is the coefficient of the x squared value, b is the coefficient of the x, and c is a constant, meaning it does not have a variable with it. First thing we're asked is if our parabola opens up or down. Now, to decide that, you need to look at your a value. If it is positive, it will open up. Ours is, so it opens up. The next thing we want is the axis of symmetry. This is a line, and so it must start with x equals. Then to find it, you need the x value of the vertex. To find the x value of a vertex in standard form, you do opposite b over 2a. Our b value is negative 12, so the opposite of negative 12 is positive 12. And then we're going to divide by 2 times our a value, which is 3. So 12 divided by 6 gives us 2. So our axis of symmetry is x equal 2. So this line right here at positive 2 is going to be the axis of symmetry for our parabola. Then to find our vertex, this is the x value of our vertex, so we can just slide that into the x slot of our vertex. And to find the y value, we put 2 in for the x's in our equation. So it's going to be 3 times 2 squared minus 12 times 2 plus 9. So 2 squared, 4. 4 times 3 is 12 minus 24 plus 9, so negative 3. Then the next thing we're asked is, does this have a max or a min? Well, since it opens up, it's going to make a U shape, so it will have a minimum value. The value of your minimum is whatever the y value is of our vertex, so our value is negative 3. Y-intercept. Remember, you find y-intercept by putting 0 in for x. So 3 times 0 squared minus 12 times 0 plus 9. 0 minus 0 plus 9. So our y-intercept is 0, 9. X-intercepts. To find the x-intercepts, we need to solve this equation by putting 0 in for y and solving. There are multiple ways to do this. We can factor if we're able. We can do the square root method, which doesn't work on this one because we've got an x term. We can complete the square, or we can do the quadratic formula. I am going to factor this. So I see I have a greatest common factor of 3, so I factor that out. 12 divided by 3 is negative 4. 9 divided by 3 is 3. Oh, I forgot my x. Then I think about things that multiply to give me 3, 1 and 3, and how can they add to give me negative 4? Well, if they're both negative. And that's still equal to 0. So then the pieces that have variables, so this parenthesis and that parenthesis, I set equal to 0. So to get x by itself, I add 1 here, so x is 1. And to get x by itself, I add 3 here, so x is 3. So my 2 points are going to be 1, 0, and 3, 0. Let's graph all those points. So our vertex is at 2, negative 3. My y-intercept is at 0, 9. My x-intercepts are at 1 and 3. And since I went over 2 and up 9 to get to my y-intercept from my vertex, I can go over 2 and up 9 over here as well. Then I draw in my parabola. Make sure to make it rounded at the bottom, not look like a V, because then it would be absolute value. So there's my parabola. And next thing I need to do increasing and decreasing. Increasing, remember, and decreasing, you're going to go from left to right. So dragging my pen across from left to right, the first thing I encounter is an arrow. I came from the left side, so that's a negative side. The first thing I encounter is my arrow, and then my parabola is going down. You see that? So it's decreasing. And decreasing began on the left side, so it's negative infinity, and it stops decreasing at the vertex. Since I'm going from left to right, I need to use the x value of my vertex. So the x value of this point right here is 2. So it's decreasing from negative infinity to 2. And that gets a parenthesis because actually at 2 it's at the bottom, so it's not increasing or decreasing, it's just at the bottom. Then, following still from right to left from here, notice my parabola is going up now, so I'm on increasing beginning at 2, and then the last thing I encounter is an arrow, meaning infinity, and I'm headed off to the right, so that's a positive direction, so positive infinity. Positive and negative has to do with my x-intercepts here. So again, from left to right, left, first thing I encounter is an arrow, meaning infinity, came from the left side, so that's negative infinity, and my graph is positive because it's above the x-axis. So on the positive, I'm going to start with a negative infinity. And where does my graph stop being positive? At the x-intercept, the first one I encounter, which is 1. Then my graph down here is negative, so from left to right, 1 to 3 is negative. And then after 3, it becomes positive again to infinity, this time on the right, so it gets a positive. Remember, positive is when it's above the x-axis, negative is when it's below. The arrows are going to tell you which side it gets 2 sets of parentheses. Also remember, we are using parentheses because at these values of 1 and 3, our range is, or our y value is 0, so our y value is neither positive nor negative. That's why they're getting brackets and not, or sorry, I apologize, that's why they're getting parentheses, not brackets. Domain, same for every parabola, negative infinity to infinity. The range goes from the bottom to the top, so use your pen, drag it along. This is the first y value you encounter, so make sure you're using the y values, the ones on the y-axis. Negative 3. And then the last y value I encounter are arrows, so that's an infinity. Oops, that's a really poorly drawn infinity. Now this is the only place on your parabola where you'll have a bracket, because the parabola actually exists on negative 3.